Another explanation, again, balancing chemical equations, practice number 3. This time it's problem number 5. This one has a little bit of a twist in it because we have something you probably don't know how to figure out the formula for, hydrochloric acid. Okay, now again, because it is an acid, you don't know the nomenclature, I gave you the formula for that. So this is the formula for hydrochloric acid. So we're going to go ahead and we're write out aluminum hydrochloric acid. They're going to react to form aluminum chloride and hydrogen gas. So let's go ahead and start off by writing down our aluminum. So our symbol for aluminum is Al. And again, if you didn't know that, you need to go back to your periodic table and figure that out. We're going to add to aluminum some hydrochloric acid. And again, that formula is HCl, and that's a lowercase l. That is going to create or form aluminum chloride and hydrogen gas. Now, aluminum chloride, it is a type 1. We know there's no Roman numerals, so we don't have to worry about that. So we have to go ahead and figure out what are the charges for aluminum. So we're going to go back to our monoatomic ion sheet. So all the way back down to page 13. Okay, in this case, it might be page 14. It says page 12, but that's an old one. So we're going to look at aluminum. Aluminum is a +3. Okay, so aluminum is +3. The other one we had to look at was aluminum chloride is a -1. So if I get rid of that, I can go back up here and I can say that my aluminum is a +3 and my chlorine is a -1. So we have that. Now again, they don't cancel each other out. So what are we going to do? We're going to crisscross. So we're going to put a 1 right here, and we're going to put a 3 right there. So again, +3 times 1 is +3. -1 times 3 is -3. They cancel each other out. So now we have the right ones in there, plus hydrogen gas. So we'll go ahead and we'll put in aluminum, Al, and then we have Cl was for chlorine, but we have to have 3 of them. Okay, we didn't put down the 1 because without a subscript, we know that there's at least one of them there. Okay. To that, as another byproduct, we're going to have hydrogen gas. Now, again, we have to look to see if we have any type of element by itself, aluminum and hydrogen. Are they diatomic? Okay. So how do we figure that out? Again, we go back to our periodic table. We look for those 7 elements if you don't know what they are. Okay. I always like to double check. And remember, they make a 7. And here it's nitrogen, oxygen, fluorine, chlorine, bromine, iodine, plus hydrogen. Okay, don't ever forget hydrogen because there's only 6 right here, and we have 7 of them that make a 7 on the periodic table with hydrogen. So we go back here, and we see that aluminum is not one of those 7, but hydrogen is. So we're going to go ahead and put a subscript of a 2 there, so we know that it is diatomic. And after this, we're going to go ahead and put in our molar ratio, and that'll be where we put our answer here at the end. So now we can go ahead and set up what we have on each side. So we're going to go ahead and write down here we have aluminum, we have hydrogen, and we have chlorine. Now I do not have any polyatomic ions on either side. So those are the only 3 elements that we have. So on this side we have how many aluminum? Correct answer is 1. How many hydrogens? 1. How many chlorine? 1. On this side, we have 1 aluminum, but look at, we have 3 chlorines. So we're going to put down a 3 right there, and we have 2 hydrogens. Okay, now I would normally say we're going to save the element that's by itself for the end, especially if I can just put any coefficient in front of it. Remember, we can't change the subscripts on any of them, because that is the formula for those compounds. So we're going to start off with, in this case, I would start off with chlorine. Now, the reason hydrogen, because it's by itself, I just need to make sure I have to have a 2 over here in order to be equal to that, because they have to be even. So we're going to start off with a chlorine, and I have 3 chlorines on this side, so I need 3 on this side. So I'm going to put a 3 right there. So now I have 3 chlorines. But I also have 3 hydrogens. Okay, so now my hydrogens are 3, And now I have an opposite right there. So now what do? I have odd on this side, even on this side. What I like to say is we're going to double them. So if I take this right here, or make it a double them or make it a 6. Okay, sometimes 3 times 2 is 6, so we're going to make this a 6. So we have 6 hydrogens. Okay, so I can go ahead and we're going to put a 6 right there. Okay, so now you make 6 over here. So what goes in front of there is it going to be a 3. And so now I have 6 on this side. But when I put the 6 here, I changed what I had for the chlorine. So now I have 6 chlorines. Again, so I'm going to have 6 chlorines. And so I need to have 6 chlorines on this side. So the only way to change 6 chlorines on this side is to put a 2 right there. So 2 times 3 is 6. So now I have 6, but what did I affect? I affected the aluminum. So we're going to change that to 2 times 1 is 2. So I have 2 aluminum there. And so now I have to come over here and make this a 2. And the only way that I'm doing it is if I put a number in front of it. And we'll put a 2 right there. So now I have 2 aluminum on this side, 2 aluminum on this side. I have 6 hydrogen on this side. I have 6 hydrogen on this side. I have 6 chlorine right here on this side, and I have 2 times 3 for 6 chlorine on this side. And so now we're balanced. So what is my molar ratio? My molar ratio is going to be 2 to 6 to 2 to 3. So I look at it and I say, well, can I reduce? I can't. I can reduce everything by 2 except for the 3. So I can't reduce that. So we are good at that point. So we're going to go ahead and highlight that with our color. And there's our answer. That's our molar ratio for this balanced chemical equation is 2 to 6, 2 to 3. Good luck with everything else on the rest of it. And as always, go Mohawks. Nelson out.